Hi, y'all. Welcome back. We are in Engineering 11. We're looking at graphics, so we're going to stop talking about floating point numbers now. In this section, or in this session, as I think I call them. So we just finished this. We're going to go on to our introduction to graphics, which we'll do in just a minute. What I wanted to show, though, is during break, I just wrote some back of the envelope calculations. So, and I wanted to show you a numerical experiment. So I asked you a question at the last part of this thing, which is what is the absolute largest floating point number, normalized floating point number that I can store? So the claim of that was positive. The exponent bit would be basically all ones except for the last one, right? And then in this case, the mantissa would also, the significand would also be all ones. And in the case that we have all ones except for the last bit in the exponent, we actually have 53 ones, only 52 of which are stored, right? So in that situation, when I was looking at this, I thought to myself, okay, well, what would it mean to have 53 ones? Well, just do it as an unsigned binary integer. In an unsigned binary integer, 53 ones would be 2 to the 53 minus 1, right? But then what I want to do is I want to shift the 53 ones so that the point is right before the first one, right? So in order to do that, I'm going to divide by 2 to the 52. So this number right here, that's what fixed point was all about, right? It helped us understand how the binary fractions were stored. So this number right here is that number, I believe. Right? Okay, so now what I want to do is, now that I have this number as so this is now times 2 to the 0, basically, right? I want to shift the exponent up by its maximum value, so I just take that number and I multiply by 2 to the 1023, right? Okay, and then the claim is that this should be my corresponding integer, binary representation. The first 12 bits, which are 3 nibbles, are going to be determined by the exponent field, and then literally I'm just going to max out the significand field, right? Which means that my corresponding hexadecimal would be 7FE followed by 13 Fs, right? Okay, so that was a guess based on my understanding of how binary encoding works, and then I just tested up that guess, and look what you see. Okay, so now my question is, what if I wanted to break MATLAB? What number would I need to add in order to increase the exponent field by 1? So here's the claim. If I add, in this number, if I were to add 2 to the negative 52, right? So 2 to the negative 52 would be, if I added that thing, it would hit the last digit, right? So the last digit would go up to 0. These would all propagate down, and then the leading bit would go to the next bit, in which case we would move this thing to the left, and we would increment that by 1, right? Okay, so if I added 2 to the negative 52 to that number, I would increase it, but the problem is 2 to the negative 52 to that number is not the same thing as adding it to this one, right? So the claim is if I add 2 to the negative 52 times 2 to the 1023, well, what is 1023 minus 52? Sorry, I don't need format long. Okay. So if I take this number, and then I add to that 2 to the 971. Claim. If I were to add 1 larger, it should not max out. Is it 1 smaller? I mean, one thing to do what I really want to do is I want to show the absolute last thing that I can add. We don't have to go. I don't want to spend 45 minutes on this. What I wanted to show you, though, is the moment that I now know this encoding, guess what I now have control over? My brain, which means I have control over MATLAB, right? I can start engineering experiments to figure out what the capacity of my data class is on the upper end and the lower end, and then I can also start really analyzing using mathematical symbols, in fact, where my data classes break down and what type of errors propagate through my system. So I'm going to shut up about that. I'll write some very fun things for you. These are the back of the envelope calculations. I don't want to spend too much time on that, but those are some of the things that can happen. What I want to do next is I'm going to do a new script, actually. And in this case, I don't really want to spend time writing code because, writing documentation, because this is literally a sandbox. So I'll call this graphics sandbox as opposed to graphics construction site, right? Okay, so what I want to start talking about is the graphics representation. One of the first things that I might do is represent, so in MATLAB documentation, there's a very nice introduction to graphics that I'm going to show you. Let's go ahead and do this. So we're going to switch gears for a moment. And graphics, 2 and 3D plots. What I wanted to show you first was just how easy it is to make a plot. So let's do x goes from 0 to 2 times pi. If I don't tell MATLAB what discretization I'm going to use, what does MATLAB automatically use for my delta? 1, right? So in this case, I'm going to actually tell MATLAB, hey, I want you to use increments of 0.1. What does 0.1 mean? 1/10. Kind of makes sense that it would go up to 6.2 because pi is 3.14. 3.14 times 2, 6.28. Okay, so now in y, anybody have a favorite trigonometric function? Damn it. Cool, that's really awesome. Anybody have a different sine? Okay, that's really exciting. So let's do sine of x. Thank you. Okay, so let's check this out. Now what I'm going to do is I'm literally just going to plot x versus y. So when I run this code, there it is. I think I saw it. Did you see it? Oh, I know what the problem is. I got to run the damn thing, right? Okay. That may or may not help. I might actually do something that all of my students are geniuses, really, right? But this particular genius taught me how to do duplicate screens using FN, so that was really fun. So now everything that we're going to see together. Okay, so this thing right here is called a figure window. And within this figure window, we have a lot going on. Notice that MATLAB has outsourced the size of the window as well as all of the things to automatic calculation, right? Let's imagine for a moment that I did go up by 1s. Did you see how I just changed that? And let's run it. And I always, what do you notice? So what type of interpolation is MATLAB using here? Yeah, linear interpolation between the points. So the only reason that, in fact, we can do a whole cubic spline. There's, shut up, Jeff. Just keep it easy. The only reason that MATLAB, it would be nice. I always forget how to dock this damn thing. So let's Yeah, there it is. So the only reason that this looks smooth is because our human eyes, so if we look at the size of y, how many points are we in there? 63. So literally within this really small bit, there are 63 different things that we look at. If we were to zoom in, say it again.
Pixels, like how thick the pixels are, you may not even be able to tell.
You see it? Do you see the little dot right there? And in fact, what we can do here, so this is where I'm going to teach you to kind of use documentation. And we'll go through this together. Don't worry, you're not going to be alone on this. But I do want to show that like you have a lot at your fingertips. Let's just go ahead and look for one where we actually mark the individual points that we're graphing. So there's one that's kind of nice, right? So check this out. B dash dash O. Could you guess what B means? Blue. Dash dash means the line is dash line, not a solid line, and O means put a circle around the point.
I think blue means purple, or B means purple.
Yeah, it could be yeah. So let's do it as a string B dash dash O. Sorry. And let's run the darn thing. What are you noticing? Yeah, and in between, let's go ahead and turn it into a line. So now there's a solid line in between those points. If I were to be crazy and actually individually count the number of circles on that, how many should I expect? 63, one for each data point, right? Okay. So now the question is, well, what if I wanted to get a sense of all the different plot options that I have here? And then this is where I would just say documentation. So check this out. We'll talk about subplots in a bit. We're going to do all of this together, don't worry. So they just get showing you a bunch of examples, right? So line styles, what does line style mean? Solid line, dash line, dotted line, dash dot. Dash dot, oh, I actually really like dash dot, to be honest with you. It's like one of my favorite line styles. Could you guess what markers mean? Say it again, pentagram? Should we do that one? Yeah, let's do it. So let's do a dash dotted line in, I don't know, green with a pentagram. Because literally, I was just thinking this morning, do you know what I need more of? Oh yeah, the line right there is the problem. Right? I need more pentagrams in my life. Oh, I see. Yeah, the dot is the, yeah, there we go. Pentagram, I guess, means star. Let's undock this sucker, and let's make it real big. What's really cool about this is I can actually now print we're going to get into this. There's a lot to this, right? I can print these, I can save them, I can embed them in LaTeX code if I wanted to. And I'll show you how to, yeah, it's pretty amazing. Okay. Anybody see some stuff you want to change? I don't know, yeah. Okay, I don't know how to do that off the top of my head, so that's an open question. One thing that I might say is, what if I wanted to do a cosine on the same graph? So sometimes you can abuse this. One of the things that I'm going to say, I want to talk about what we call a root object. So there's something in graphics called handles, and we can think about handles as point. Anybody take C programming? The idea of a pointer. Say it again. Yeah, C++ is a pointer. I'm still, this is the first time I taught this, and I haven't had a chance to write it up yet, so you're going to have to stick with me for a second. Anytime we create a graphic, MATLAB is going to speak with our operating system, and they're going to talk about what they say. So in this case, we're going to say let f be equal to the figure command, and we'll call it figure 1. So we'll call figure 1, figure 1. And then what I want to do, so right now what I just told MATLAB is, please create this thing that we're going to call a figure. But what do you notice about that figure? Is it full or empty? It's empty. That figure has no axes and it has no actual thing that it's graphing. So what's interesting about this is if we say get fig 1, in the background, you're going to see a ton of information about what's stored in a figure. Every single time I create a figure, MATLAB actually has what they call a data class. So it's an entire class of data stored. Look at how many different subclasses are involved in this. Alpha map, being deleted, by action, button down, children. Any children? This thing has no children yet, right? The reason that it has no children is I haven't told MATLAB what thing that I want to plot with the figure. Clipping, color map. And it makes sense this would be 64 times 3. Could you guess why we say 64 times 3? RGB, probably, right?
Very specific.
Parent? Who's the parent? Parent is the class of objects above a figure, and in particular, the parent is the screen. So in MATLAB, we call the root object the parent of all figures. You don't have to worry about this today. The reason that I want to say this, though, is that we actually can do a lot using the idea that every time I call a figure, I'm going to tell this. So right now what I'm about to say is, hey, MATLAB, I want you to create a data class. What's that data class called? Figure. Which figure number am I storing here? Figure 1. The moment I run this piece of code after that piece of code, could you guess what I've just done? I've just birthed a child. I have just said, hey, in figure 1, I want you to populate figure 1 with this plot. So now when I run it, check this out. Figure 1 is populated with this plot. Now, if I were to do something different, let's go ahead and do y2 equals cosine of x. And let's go ahead and plot x versus y2. And in this case, we'll do it in, what is this? Blue, double-lined. Wasn't there a hexagon option? Okay. What's going to happen here? Whoa. What happened? I mean, we could do it again, right? Let's do it again. That time you couldn't even see it, right? So what happened was, hey, I told MATLAB, hey, I want you to grab figure 1 and I want you to populate it with this graph. But then I automatically allocated a new graph, and what did MATLAB do? It overrid it. So one of the things that I can do here is I can do either hold on and then hold off. It's getting mad because I deleted this piece and I didn't close that. Okay. Now what? First thing is it graphed my first plot. When I told MATLAB to hold on, what it says is, hey, keep that original figure and superimpose on top of it my new figure. I could have also run the same code by simply adding this on top of it. Hold off means that one of the interesting things about this is pretend that I did not put hold off there. So let me go ahead and just go back here. And then I want to run another plot. So maybe we say y3 is equal to tangent of x, and I don't think we're going to have any problems here, right? And let's call this magenta. Say it again. Yeah, so if I don't say hold off, every single plot that I do is going to be on the same axes, right? But if I say hold off, what it says is after that piece of code, everything else treat as its own class. And in particular, the way that I always like to do this is if I want two different figures on two different graphs, can you guess what I could do? Create a second figure. Yeah, go ahead, Colin. Oh, weird. So we didn't capture any of that? It's probably because the is that better? So now what's going to happen when I run these two pieces of code? The child of the first one is going to be the plot of y1. The child of the second one is going to be the plot of y2. You can't see that because I now have two screens. Okay. So now, what's really nice about this is I can start talking about what type of properties I want to do. And this is actually new. So what I want to type in here is figure properties. This is new to MATLAB since 2014, I think is what I read. Okay, so this is kind of fun. Using figure properties, what can I do with figure properties here? I can control the appearance and behavior of this. I wonder if there's, oh yeah, collapse all. Let's do that. Okay, so now what I want to do is I want you to tell me which you feel most excited about. Can I zoom out on this thing? Ah, stop. Stop. You. How about dock controls? Figure docking specified as one of the following. Figure can be docked in the MATLAB desktop. So either I dock it by the little button or what? I disable the docking figure. So in this case, one of the really interesting things about this, I don't know if you can see this at the top. So here, what we've done is we said, hey, you're going to create this data class, actually, this entire set of things called a figure, and you're going to store it as this thing fig. So there's a ton of stuff going on behind this, which is really an interaction between MATLAB and your screen through the operating system, right? And then what they're saying is, hey, I can actually set individual properties by doing the little dot units, right? And I think they call this, what do they call this in object-oriented design? I think they call this objects and properties of objects, right? So in this case, if we're looking at dock controls, sorry, go ahead. Say, I didn't hear it.
This dot,
Say it again. Member, yeah. There's some formal computer science behind this that I studied at some point in my life. I haven't had the 12 hours that it takes me to like get all the language together, right? But it's there. Yeah. So if you're interested in that, you can kind of play with it. Let's turn the first figure, let's call figure 1. Let's turn the dock controls off and see the difference between the two figures. What do you notice? In figure 1, what do you see? Figure 2, I can put it into dock just by clicking that button, but in figure 1, what did you see? There's no button, right? Okay, let's try another one. And this is where I hope you're starting to notice the same thing I notice, which is coding takes time. So I don't know where my help, there it is. Okay. Background color, could you guess what background color does?
Change the color of background.
Yeah, let's do it. So let's go ahead and take a look at this thing. So let's do figure 2. What if I wanted to change background color? So I say, hey, for that object called figure 2, I want to control the property which was background color. I'm guessing they try to use the same. Oh, excuse me. That makes sense. Figure 2 color. And then I'm supposing that they probably do something like a string. So M is magenta, I believe. Let's go ahead and run this thing and see what happens. Okay. All right, what's the next one? What if I wanted to control the position of where these things come out? So it looks like if I have this figure property called position, right? I can store position left, bottom, width, and height. So could you guess what 0, 0 means? Yep. And then I haven't actually got a good answer to this. I plan on being very active in the MATLAB community sometime soon. It was not something that I did when I was in my PhD. Position. Okay, 0, 0, 100, 100. What would that say? So if so the question that I have is this is this with reference to the bottom left pixel on my screen? I can tell you right now, because I spent some ridiculous number of hours over the last few weeks thinking about this. When I run this code, it's going to put the figure on my original screen, not on this screen, not on my secondary screen, because right now they're not duplicated. So when I run this, yeah, so you can't see this right now. You can't, yeah, it's not even big enough. Let's see if I can shift it over. It would be really fun. So let's try 1,000. So if I start with the bottom left and I want to shift it to the right, the way that this computer is interacting right now is it looks at it from left to right. Let's see what happens when I run that. It's still, okay, let's try 2,000. Yeah, there it is. Yeah, okay, you want to move it up? All right, so let's go ahead and move over by, I don't know, 200. Let's see how high that is. Right? If I wanted to control I think this is pixels, though I'm not sure, to be honest with you. The way to really figure this out, do you know how to find pixel size in Office, Windows really quickly? We don't have to spend time. I mean,
I can pull it up for you right now.
Oh, cool. So I want to know the pixel size of each screen so that I can, like a sniper, tell you. I want to like find if I can put this in that exact pixel.
Oh, there
And you can do this on your, like, right, that would be a really interesting question that you have on your computer. Could you get the exact pixel location of the figures that you're creating and then put the figure anywhere you want on those pixels?
No. Awesome. You know when the GUIs pop up and they're like,
I'm not as familiar with how Windows uses its
Okay, so you have,
detect, maybe?
yeah. Oh, no, so,
Identify. Yeah, let's not spend a ton of
Yeah,
time
yeah.
on this right now. So that's an open question. Okay, so what did the position property do? Yeah, and then, like, we get, yeah, I'll let you play with that. Okay, so here's what I want to talk about. So now if I write get figure 1, notice, what's going on here? Did I delete stuff? Say it again. Say it again. Oh, I see. That seems weird to me though, because I actually have figure 1 stored. Do you see that though? So this is really interesting. We're not going to get into this. Is way more advanced than we need to do today. I've been spending a lot of time thinking about this though in the last few weeks. So what does this say? Figure 1 is a variable, and it's actually a variable that is specific to MATLAB, right? So when I write I should be able to use the code get fig 1. Okay, so that's really interesting. Let's run it in here though. Let's do get fig 1. I'm not sure why that's the case. It should be that I have both of them. Okay, there we go. So check this out. See it? Every one of these, so that command basically says, please tell me all of the values stored in the figure 1 data class. Do you see that I have now controlled this? Right? What's really interesting about that is one of the things that you might want to do in any class. So have you ever, for like a lab report or a homework assignment, you've had to graph something? Okay, but graphing it on your computer screen is not the same thing as printing that graphics out, right? So one of the things that's kind of fun about this, check this out. What do you notice there? What are all that stuff? They're dimensions having to do with how you print it, right? So it tells you, in particular, you could actually see this in the figure properties. And the reason that I want to come back to this is there's no, you could give me, I have spent literally 16 hours, this was 2 weeks ago, just dissecting all the figure properties, and I'm not even like close to where I want to be. Because this is all new. Back in the old days when we used to walk uphill in the rain, right? Every single one of these properties used to be its own bit of code. So you'd have to write a single line of code to control all of these properties. Since 2014, what MATLAB has done is it's allowed you to refer to the handle. So you have a figure, which is the child of your screen. Call that fig 1, and then if you want to change any subproperty, just say fig 1 dot whatever the subproperty name is. All of that is done in figure property. So in this case, why don't we collapse all? Is there a way to expand all, collapse all in page? There we go. So check that out. MATLAB has a broken piece of code. Collapse all, plotting, collapse all. Yeah, see it? What's this? Yep. So if I want to change the paper size, let's say that I was living in Japan and I wanted A4 paper, that would be a way to do it. If I wanted to change paper orientation, notice that if I actually go back to my code and I type in Fig 1 paper orientation equals landscape, I should always open and close those at the same place. So landscape. And then I run this thing. Did it change the representation of that figure on my screen? All of those properties, every single one of those properties, if we go back to this thing, and we looked at figure properties, this particular set of figure properties is all about what? Is all about how once I create a figure on my screen and I want to export that as some PNG file, how do I go from capturing it on my screen to putting it on a piece of paper that I can print, right? So all of those units there work in that favor. In the code that I sent you for lab 4, you'll see that I do control some of this. Kind of fun. Okay, so the next thing that I want to talk about, and I think we still have about 8 minutes, so I'll take it, is I want to talk about axes. So in this case, what I want to do is show you axes properties. And this is what I mean when I say no teacher can teach you this. What I mean is, how many of you want to spend 8 hours a day listening to me talk about MATLAB code for 5 days a week? Thank you. Should I pay you in cash or credit? That's very kind of you, right? But many of you have other things that you want to do in your life, right? So the point of an introductory class is to expose you to some of the ideas. But my claim is, I've said this since the day one of class, I'm going to say it again today, if you actually want to implement the code in a way that matters in your technical life, there's no way that under the constraints of 55 hours of lecture per quarter, that I'm going to be able to expose you to all of these concepts. Whereas if you know how to teach yourself how to code, you can actually do this. Every figure has what we call an axis underneath. So if you look at this thing, GCA is a command in MATLAB that says, hey, in the current axes, please get that current axes and then store the handle as AX. So what I mean by that is, did I tell MATLAB, this is kind of an ugly figure, isn't it? Let's undock this thing. Here, is there anywhere that I told MATLAB what the parameters of my axes should be? I didn't tell it where to start it. I didn't tell it where to end it. I didn't tell you what the y values were, what the x value were, and yet MATLAB chose an optimal value of that particular thing. Let's go ahead and change the size of this. Let's try 1,000 by 1,000. And then it looks like if I were to go like 150, something like that, and we'll call 0. Yeah, there we go. What are you noticing? Is 1,000 big enough, or is it too big? Too big. So if I want this thing to be square, maybe I do like 600 by 600. Yeah, and then it ends up that the bottom little menu bar in my Windows operating system is above that thing. So maybe I shift this up by like 200. Too much. This is called Newton's method. Thank you. I'll be here all week. A little higher, right? Yeah. That's good. There we go. Okay, so if I were to multiply this by 10, so let's take this original one and multiply by 10. What happens to this graph of sine when I multiply by 10? The amplitude changes by 10. But check this out. Did the figure change at all? Did you see that? Let's try again. So look at that figure. Do you see it? So let me move this over, maybe 1, 2, 0, 0. Oh, no. Eventually I'll figure out how to okay, so check this out. Right now, what's the axes on the y value? Goes from 10 to negative 10, right? If I change this to 1, what happened? So separate from the figure command, there's this thing happening in this particular figure having to do with axes. And I can control, so if let's say axis 1 is going to be get current axes. So you can learn a little bit more about what the GCA command is. So let's go ahead and clear. Let's do help GCA. Okay, so check this out. This is a quick thing. We're not going to go through the whole documentation right now, but what does GCA do? Returns the handle. How am I encouraging you to think about handles in MATLAB? Pointers. It's like an address, right? So think about a figure. A figure is this whole data class that has a bunch of properties that we can set. Embedded, so that the parent of figure is called root. What's another word for root on your computer? The screen. So the way to think about this is when we call figure, what MATLAB is going to say is where do you want this thing output? Well, I want to control the way that the screen looks. We're going to MATLAB calls the screen root. It's also called figure 0. Okay, so now that I'm in root, I want to create this figure window, right? So this thing, when I look at this line of code, this says, hey, everything having to do with a figure window, I want to encode for the first figure as figure 1. So that's the location that I'm going to control all places. So all these other things basically say, in that place, whatever that location is, please control these options. Underneath figure, can you guess what we're going to say? A child of figure? Axes. And you kind of saw evidence of this in this graph. Within this figure, I have what we call a horizontal axis, and I also have a vertical axis. If I wanted to control those properties, what I would do is go to axes properties. Okay. So what are some of the things MATLAB is telling me that I can do? For my axes, I can control the size of the font, which is font size, both capitalized. So let's go back to this thing. Okay, so if I wanted to control axes 1, and let's do something ridiculous, right? Font size as a string, let's do 64. And then on this one, let's call these axes 2. Let's go, I don't know if MATLAB allows me to do font size 4. Oh, I know what the problem is. This font right here, do you know, so what do you usually call these little things that run along the corners there? Tick marks. When I'm thinking about font size, axis labels, tick labels, to me that would say that the tick labels, oh, I know what the problem is. Is it stored as a string? Scalar numeric, so that was a misread there. There we go. Do you see what MATLAB has done there? It's not as accurate because the size of my values is much higher than the actual space that I've given on screen, right? What are you complaining about? Yeah. See it? What size is that font? 4. Okay, so let's go back to 12. We can control that. And then if I go back to axes properties, all right, I'm going to go ahead and collapse all. Expand all, collapse all. This button should work. So I think MATLAB's, if I expand all on page and then collapse all on page, that should work, but it's not. And then we'll end the end of today. I don't think we're going to get to subplots today, but that's okay with me. So either MATLAB has some error in its documentation code, or my computer is misbehaving. Check this out. What does this allow me to do? Say it, yeah, you can say it out loud. Change the tick marks. You really want to piss off?
So that they know what the values are.
Yeah. Be nice if I could collapse all. There we go. Check this out. Tick direction. This one actually I have some issues with. I get really upset when the ticks are inside the graph. Something that kind of bothers me. So if I go back to this thing, I can actually say, hey, for my axes tick direction, please point them outwards, not inwards. Did I miss something? Oh, tick dir. Okay. You notice it?
Yeah.
What happened? Yep. If I move this to both, could you guess? Moved in and out. And then the claim is, if I were to go back to axes properties, what if I wanted to control grid lines? So I can also control the lower and upper bounds in units. We can talk more about that in a bit. Check that out. What is this telling me? So I can remember again, when I do this thing right here, I literally have now an address to the axes data class. If I say X grid, and I forget what that looked like. What did it look like? X capital GRID. On, what happens? Anybody see something that immediately you might want to do if you can turn the grid on? Make it darker, make it thicker, make it less thick. What do you see? Okay, let's turn it into a dashed line. So grid line style. AX1. I think if I do grid line style, I don't know if this is going to work. I believe I figured this out. Use the grid command on the xgrid property on. So what if I did xgrid dot grid line style? What happens there? Okay. There is a way to do this. I have figured this out for myself. If I wanted to turn, and then I'll stop now, but what I want to show you is like all of this is, I'm sorry to say, like the somehow grid color. Let's try that. Grid color. Why don't we do blue? I mean, the point of this today is to introduce you on your lab 4, and we'll talk about this right when we get back. You're going to learn how to use all of these figure properties and also axes properties to graph some of the work that we did in the pendulum, right? Eventually, I have no doubt. So the funny thing about this for me is when I did all these figures way back in my old days, I had memorized the lines of code that allowed you to control this without access to the data class, right? So what are you seeing now in 2020? I don't have to write individual lines of code to control this. All I have to know is the name of the appropriate class, right? So the more you work with this, the better. I'll shut up for now. That's an introduction to MATLAB graphics. Can we finish Lab 4 introduction now, and then I'll just shut up for the rest of the day? Is that all right? Okay. So here, if you go down to Lab 4, there are 2 pieces of Lab 4. Hopefully you had a chance to take a look at Problem 2. Problem 2 is all about writing a data class, which is called a uFix data class. So there's a function that allows you to take in an integer and figure out whether it's a power of 2. And then there's another function that if I tell you numerator, denominator, number of bits in the leading parts, number of bits in the fractional part, I want you to create a string of zeros and ones. Yep. I would like you to do checks. So in error checking, I would like you to do a check to make sure the Q in this case has some value in between. And to be honest with you, the expected data class is uint 64, right? Yeah. Yep. And then the really interesting thing about that is we're going to translate this into a uFixed 8. So you got to understand what uFixed 8 is talking about, what the parameter P, which is the numerator, parameter Q, which is the denominator, L is the number of bits for the leading part, F is the number of bits for the fractional part, and then B is a string of ones and zeros. So it's a 1 by 8 vector. I want this to be in big endian. So I want it to be in the left one is the most significant bit, all the way down to the right one, which is the least significant bit.
Does it have enough kind of redundant? Because F is just doing itself.
Yeah, I mean, once you know L, you know F for sure. That's not false.
But it's like run a check to see if L
Plus F equals 8.
Q otherwise spit there.
It's not Q, right? In this case, how many bits are dedicated to this data class? 8. So L plus F should be 8, right? The claim, though, is that if you solve it for 8, guess what you solved it for?
Yeah, that's right.
16, 32, 64, M, in fact,
If
right?
L's 5, F is going to be.
It must be 3. Yeah.
Yeah. They're just included anyway, even if you're not going to use
Yep. Yep. So I'll let you kind of play with that. It's a fun coding problem for sure. And then, you know, the last time I ran this one, I think I had something like 7 different solutions to this problem. Like completely different lines of code to solve whether or not to figure out something's a power of 2, which is really fun. Like, what's that? You can do, yeah, you can use, there's actually embedded, hint, there's a MATLAB function that you could solve this in one line. Yeah, which is kind of fun. If you've already solved that in one line, maybe you find a different way to do it to challenge yourself. But I always say, like, protect your other classes too. The other one that we're going to do is kind of play around with the data from the pendulum. And in particular, I've produced some plots for you. So this is kind of fun. I actually exported this as an EPS and then imported it into my LaTeX file. So I'm going to be asking you to recreate this code. I've actually given you this exact code as a gift online. So if you were to click on this thing right here, that's a .zip file. If you save it and open it, this is updated since last week. So last week I had stored this in lab 3. Now I've moved it to lab 4. So I gave you the lab 4, what I would call main if I was a C programmer. In this case, you could call it the script file that controls it. We'll talk more about this on Wednesday when we see each other. For now, I kind of want you to have to read other people's code because that's a really beautiful way to learn why you should write good code. And then if you open the other file here, I have a plot position function that is better documented. It's not great, but it's better. I give this a solid C. What did this author do? Read through the freaking documentation and then targeted like a sniper the individual pieces. Yeah, there it is. See it? I knew I could control that. What am I doing right there? For this particular graphics, I want to get a hold of the handle for the axes. Then I want to focus on the X label. Could you guess what X means? It really should be horizontal. Could you guess why MATLAB coders didn't say horizontal label? Yeah, well, that and we have finite storage. Horizontal takes however many strings. X takes 1, right? So anytime you see the word X in MATLAB, that's the horizontal. Y is the orthogonal in the plane, and then Z is the third one using the right-hand rule from Math 1C, right? So what this thing does is it gives you some ideas about how to produce that code. So in fact, if I were to comment this out and then comment this in, let's overwrite it, and then run this, MATLAB complaining about. Oh, it doesn't have the pen data. Fuck. Where would you get the pen data? Yeah, in the next iteration of this class, I'm actually going to bring my physical pendulum into class, and then every one of my students is going to do their own. They're going to use their iPhones to film a 30-second section of it, right? So that you can really feel the pain of it. Because this seems easy, right? You didn't know that like filming and building process takes like a few hours. So here's the pen data. Download it, put it in the file, learn how to update it, etc. So if you look at this prompt, that's the first one which I've given to you. Here's the next one. Then we have the velocity. Then we have the acceleration. What are you noticing about the smoothness of these curves? Claim this error comes from the fact that he's using a second order differential equation solver like finite element probably. We'll talk more about that as time goes on. And then this one's kind of fun. Next time we see each other, I would not worry about this today. This is a subplot. So claim this is a single figure. It's really beautiful. Thank you. And in that figure, I'll let you kind of zoom in and play with it. What are you noticing?
That's not right.
There's some error. And it has to do with, you uncovered that almost the first day you played with this data. I'm going to let you play with that. Yep. So I'm going to shut up now. You've got two really good lab problems that I think are going to take you quite some time. Hopefully you had a chance to start those between the last time I saw you and today. The goal of this lab is to submit your work by Monday. That's hefty. I think it's doable. Okay, can I shut up? Any questions for me? I love your questions. I wish I could pay you money for your questions.
I don't think that's something.
Oh, okay, that's a single one. Any questions that you think other folks should know? All right, I'm going to shut up. I'm going to pass out your Lab 2 results. Hopefully I'll have Lab 3 sometime within the next 7 days as well.